area of prisms and cylinders, surface area is if we had a figure, right, a geometric figure, we're going to paint it. How much paint do we need? Like, what are we going to paint? So I'm talking about the surface, obviously the outside, and then area. So I'm talking about the area of the outside. And then prisms, we might not be that familiar with, which we'll get very familiar with today. And cylinders, they look like a soda can. So you guys are familiar with those. So let's write this thing out. Prism. Prism is a solid geometric figure whose two end faces are equal and parallel, and whose sides are rectangles. The prism is a solid geometric figure whose two end faces are equal and parallel, and whose sides are rectangles. I'm going to have some pictures coming through the notes. You guys want to copy them to help you guys out, remember later, go for it. I'm not going to hold you guys responsible for them, but it will help if you guys at least try to draw one of them. So prism is a solid geometric figure whose two end faces are equal and parallel, and whose sides are rectangles. I have some examples here. And now for you guys here in class, I have a figure here, which is a prism. What it's talking about is two end faces, right? The face is the side. If you guys notice, in my case, I have an octagon, that's a face, and the opposite, obviously, it's an octagon as well. So it says two faces are equal and parallel. I show you guys that they're equal, and if I stand it one on top of the other, they're parallel. So they're equal and parallel, and then everything else are rectangles. You guys notice my sides are rectangles. Remember, prism, what it makes it is two faces, or bases we call it sometimes, two bases that are equal, and everything else are rectangles. So that's a prism. Let's continue with our notes. Prisms have two names. So prisms have two names. The first name is the shape of the end face, and the second name is prism. For example, triangular prism, pentagonal prism, etc. Prisms have two names. The first name is the shape of the end face, and the second name is prism. Think of them as a family. Prism is the last name, and then the first name is the shape of the base. In my case, the base is an octagon, so I'm going to call this octagonal prism. Let me give you guys some examples. We have a triangular prism, because the bases are triangles. We have a square prism. We have a rectangle prism. I have pentagonal prism, hexagonal prism, octagonal prism. It could be whatever shape. So obviously the shape of the base and prism. So those are the two names. Can I take this off? No? Remember, what it makes a prism is two bases, two end faces we call sometimes. So two faces and rectangle. That's what prism is. Right, can I take this? Is anybody still copying this? Okay. So prisms can be opened as a rectangle and two bases. That's an example. I'm going to show you guys two cases. So prisms can be opened up as a rectangle and two bases. If I had a hexagonal prism, you notice if I was to make it flat, I have a big rectangle and two hexagons. If I have a triangular prism, I have a big rectangle and two bases. No, the pictures don't have to draw them. They do help if you guys want to draw them. I don't expect you guys to. So this one, this figure that I have, if I was to make it flat, like it's not flat right now, but if I was to make it flat, I would have two bases, right? My octagons in this case, and this center opens up to be a rectangle. So that's why I said prisms can be opened up as a rectangle in two bases. The surface area of a prism is perimeter times height plus the area of the two bases. Well, you guys copy that. I still have some more notes after this, some more words. But while you guys are copying it, let me pass out your worksheet. Prisms can be opened up as a rectangle in two bases, and you're saying that the surface area of a prism is perimeter times height plus the area of the two bases. And I'm calling it perimeter times height for the big rectangle in the center. So if you notice on the hexagonal prism, right, figure at the left, notice how the long side is broken down into 6 parts because it's the perimeter. Right? So if I was to make my side, my shape here, if I was to make it flat, the long side is basically what wraps around the base, which is the perimeter. And then the short side is the height of the prism. So that's what I'm saying. On the surface area is going to be perimeter times height, which is the rectangle in the center, right? Perimeter times height. That gives me the area of the rectangle plus the two bases. And I didn't write which formula for the base because it could vary. Right? The base could be a triangle, the base could be a rectangle, or it could be an octagon, or whatever shape it is. So it's a big rectangle and two bases. And once again, for the rectangle, I'm just going to go perimeter of the end face, perimeter times height. Now cylinders are similar to prisms. I have a figure of a cylinder. If you have one that we can think of as like a soda can, they almost look like a cylinder. And I can make it flat, which is two circles, the top and the bottom, and a big rectangle on the inside. Now the surface area of a cylinder is circumference times height plus the area of the two bases. On prisms, the rectangle, the one on the inside was perimeter times height. Now here for the cylinder, I'm calling it circumference times height, which you guys know that the distance around the circle, we don't call it perimeter, we call it circumference. But still the same thing. So cylinders are similar to prisms. So get the area of the rectangle plus the two circles. And we know how to get the area of circles, so we're good. Any questions so far? No? All right. Still see pencils moving. Is anybody still copying this? Okay, I'll wait. My idea for today, prisms and cylinders, the surface area, it's a big rectangle and two bases. Right, that's basically it. Remember, I told you guys that a base is what it stands on. So I call it base, the end face, I call it base because that's where I extend the prism on. Right, it stands on the base. I said our base is our feet, because we stand on our feet. All right, can I take this off now? All right, so now let's take a look at our worksheet. One thing that I will encourage you guys to do is draw your figure. Right? Make it flat. Draw it. So it says find the surface area of each figure. Round your answer to the nearest tenth. So if there are any decimals, round it to one decimal place. So round it to the nearest tenth. Leave your answer in terms of pi for answers that contain pi. So those are circles. So if there are any circles, leave pi as a pi. So for this one, like I said, draw this. I'm going to draw a big rectangle. Big rectangle in the center. And my bases in this case are what's that, pentagon? So 5 sides. I'm going to draw it the best that I can. Once again, what helps out is draw your figures. Draw a big rectangle and then draw your 2 bases. You don't have to be that perfect, but it will help you guys out. I said the area of the big rectangle, it's perimeter times the height. So the perimeter, each side is 12. There are 5 sides. I'm going to say the perimeter of the base is 60. Right, the figure of the interface, the perimeter 60, and I'm going to multiply this by 7. The perimeter of the pentagon, and then the height of the prism. The height, it said 7. It's a number that has nothing to do with the base. The number has nothing to do with the pentagon. The 12 is the side of the pentagon. The 8.3 at the bottom, that's the bottom of the pentagon. The only number that has nothing to do with the pentagon is 7. So that's why I'm calling it 7 is the height of the prism. And remember, the 60 is the perimeter of the pentagon. Each side is 12. There's 5 of them. So the perimeter is 60. Remember, the perimeter of the pentagon times the height of the prism. How much is 60 times 7? 420. So the area of the rectangle is 420. So if I'm thinking of a prism, the area of the sides. Right, I'm going to have 420. Now for the base, for the pentagon, I remember for area of regular polygons, I told you guys it was going to be 1/2 times perimeter times apothem. So I'm going to go 1/2 times 60. Remember, we already figured that the perimeter was 60 times 8.3. All right, get a calculator figured out. Let's see, that's 30 times 8.3. That's 249. Okay. So each pentagon is 249. Now, for me to know what's the surface area, just add all 3 numbers. 249 plus 420 plus 249, that's what, 918? Yeah. 918. Remember, I said it's a big rectangle plus 2 bases. Now the rectangle is the perimeter of the pentagon times the height of the prism. Now for the area of each pentagon is 1/2 times perimeter times the bottom. Now let's take a look at question number 2. Once again, draw it if you can. It helps out a lot. So I'm going to draw a big rectangle in the center. What's the shape of our base? Triangle. Nice. So the shape of the base is a triangle. I'm going to do 2 triangles there. For the big rectangle in the center, it is the perimeter of the triangle. Right? The triangle has 3 sides. One of them is 12. The other one is 12. And the little one, I'm going to say it's 5. add the three sides, 12 plus 12 plus 5, want to call that 29? So the perimeter of the triangle is 29. I'm going to multiply this by 7. The number that has nothing to do with the triangle. 29 times 7 is what? 10, 203. Now for the area of a triangle, I now have to go 1/2 times the two numbers that cross at 90 degrees. Right, so look for your 90-degree symbol. It's made by 4.9 and by 12. 4.9 and 12. Those are the two numbers that cross at 90 degrees. So I have to go 1/2 times 4.9 times 12. 29.4. Let me write 29.4. I'll tell you right now. My 29 in the center of the rectangle, I added the three sides of the triangle. 12 plus 12 plus 5. That's how I got the 20. For the triangle, you talking about this 29.4 here? Yes? The perimeter, you add the sides. We multiply the areas, but for perimeter, so remember when I covered this not so long ago?
Like, you know the 29, you added those, and then on the other one you multiply it.
Yes, because perimeter, imagine perimeter is the fence. Like imagine that's a yard, perimeter is the fence. So you're talking about the edge. Right? You add the sides. You're talking about the fence. The area is 29.4. That's the grass. You're looking at a yard.
Oh, is it
that's the grass.
They were all 12. That's why you just multiply. And since this is 5, there's 5 instead of 12.
Well, the 29 in the center, the perimeter. Let me just take a look at my triangle here. Let me write it out. The sides of the triangle are 12, 12, and 5. Right? So if I look at the fence, just add the three sides. 12 plus 12 plus 5, that's 29. That's where I got the 29 from the center. Right? Perimeter times the 7, which is a number that has nothing to do with the triangle.
But then why on the other side of the one that you multiply?
Because the area of a triangle, you always go 1/2 times the two numbers across at 90 degrees. Remember the area. Remember when I used to tell you guys the area is how many squares are there?
Wait, no. No, because in the other one, wouldn't it be like multiplying times 5 because they're all 12 and that one has a 5 instead of a 12? Like, for example, if it was 12, 12, 12, instead of adding 12 plus 12 plus 12, you just went 12 plus 3 and it was 36. The same as adding. And on the other one, they were all 12. That's why we multiplied.
Yeah.
That's why we were confused.
That's why you guys are confused. Okay, on the previous one, the previous question, they were all 12, 12, 12, 12, 12. And instead of going 12 plus 12 plus 12 plus 12 plus 12,
Multiplied it times 5.
12 times 5.
Yeah.
Even they're all the same size.
Yeah.
But in this case, they're not all the same size. So yeah, 12 plus 12 plus 5. Does that make sense?
Yeah.
Yeah? Okay, cool. Thanks for asking too. All right. Any questions on how I got each of those numbers? We're good? All right, now for the end, just add everything. That's what, 261.8? Yeah. All right, once again, at the end, just add the three areas. Guys, pay attention up here. Now I see why our grades are so low. Pay attention. Let me take a look at one more question. All right, when there was a figure that was not a rectangle, right, in question number 1 and 2, it was easy to tell which one was the base, right, the shape that is not a rectangle. But in question number 3, they're all rectangles. But to help you guys a little, I marked the rectangle that I want you guys to consider as the base of the figure. So I know I have to do a big rectangle in the center no matter what. There's a big rectangle in the center, and now the bases are also rectangles. You notice how I marked the 90 degrees? So when I talk about the base of the prism, I'm talking about the blue rectangle. So now, for the big rectangle, I have to do the perimeter of the blue rectangle, right? Add all the sides. 6, 2, 6, and 2. How much is that? 16. Right? The perimeter is 16. I added all 4 sides. I had different numbers, so I couldn't just multiply. 16 times what? 7. Right? The number that has nothing to do with the rectangle. Now, how much is 16 times 7? 112? 112. So the area of the big rectangle is 112. Now, the area of the small rectangles, right, in our case, the blue rectangle, what's the area of the blue rectangle? Remember, always focus at a 90-degree symbol. 6 times 2. There's no half on this one because it's a rectangle. Triangles have a half, but not rectangles. How much is 6 times 2? 12. So each of those rectangles is 12. Remember, we covered area of rectangles last week. Remember, I said for area of a rectangle, multiply the two numbers that cross at 90 degrees. In this case, 6 and 2. Now at the end, just add everything. 136. Doesn't seem like we're quite there. So let me do question number 4. Once again, graph it if you can. So I'm going to draw a big rectangle. And then my bases, in this case, are hexagons. Right? 6 sides. So draw it as best as you can. Now, what's the perimeter of a hexagon? 36. Okay, so the perimeter is 36 times 8. Good. 288. Good. So the big rectangle is 288. Yes.
So you always look for a smaller number twice?
Not always.
So the bigger number is the one that has nothing to do with it?
Not always. Because it could have been a 1. Remember, what I do here is the perimeter of the hexagon. So you could add all the sides. 6 plus 6 plus 6 plus 6 plus 6 plus 6, which is 36, times 8, which is a number that has nothing to do with the hexagon. So 36 times 8 gave us that. Now for the hexagon, once again, I'm going to go 1/2 times the perimeter times the apostrophe. But I know 1/2 is just 1/2. The perimeter is 36. Right, we solved it earlier for the rectangle. So we know it was 36 times 5.2. That's 93.6. All right, 93.6 again. Now, just add all the sides. Right, 93.6 plus 288 plus 93.6. What do you guys have? So what? 425.2. 475? 475.2. right? Excluding cylinders, because I haven't looked at a cylinder yet. Excluding cylinders, any questions? No, we're good. All right, let's take a look at a cylinder now.
I still don't get how you get the first number.
The big on the rectangle.
Yeah.
Because remember, I went 36 times 8, right? Is that the way you're asking?
Yeah.
The 36, you see your hexagon? Each side is 6. See how I marked them the same way? So this is 6, 6, 6, 6, and 6. Add them all. That's 36. That's how we got the 36. Where's perimeter? Now we're good? Alright. Now, let's take a look at cylinders. Number 9. For this, I know I have to do a big rectangle. Now my bases are circles. So I'm going to treat it the same way. The information that I do need are radius and diameter. I need both. I need radius and I need diameter. The 20 that I see there, is that the radius or the diameter? Diameter. So how big is the radius? 10. Alright, so we need both. Now for the big rectangle, remember I told you guys that the distance around it, we call it circumference? And then the circumference is diameter pi. Since my diameter is 20, I'm going to say the circumference is 20 pi. Now I'm going to multiply this by what? By 7. So I'm going to go 20 pi times 7. It's going to be 140 pi. And I'm leaving pi as a pi, not as a decimal, because it says leave your answer in terms of pi. So the big rectangle is 140 pi. Now for the circles, I need radius of metal. Right, the radius is 10. What's the area of the circle? 100 pi. Okay. 100 because we went radius times radius, right? Radius squared. So that's how we got 100 pi. For the other circle, we obviously get 100 pi as well. Now add the three areas. What's the surface area? 340 times 5. Radius times radius. 10 times 10. Once again, what 340 pi means is 340 times pi. I told you guys to leave pi as a pi, so it's just 340 pi. Radius times radius. 10 times 10. Remember, the area of a circle is radius squared pi. So it's always going to be like the radius, you always multiply it. So as an example, if my radius was 7, as an example, if the radius was 7, the circle would be 49 pi. Right, radius times radius. So cylinders are a little bit easier. Alright, any questions at all? If you notice, today it's called what? Prisms, surface area of prisms and cylinders. For tomorrow, we have the surface area of cylinders and prisms. You notice it's the same thing, I just switched the order. Because if we don't quite get it today, I'm hoping we get it better tomorrow. So no notes tomorrow, because obviously the same thing, but for us to get. Wednesday, we do have notes. Let me take them over really quick.